Good morning, everybody. Good morning. And welcome to the last day of Build 2012. I hope this has been a fantastic event for you. And I thank you all very much for coming to this session at such early hour. I hope everything is okay. So my name is Haishi Bai. I'm a Windows Azure technical evangelist. I'm very glad to be here today to talk about advanced cloud service development. This is an advanced talk following Paul Yukovich's session on getting started with cloud services. So I would assume you already know the basics, such as web roles and worker roles, how to make and deploy a cloud service using Visual Studio. And if you don't know any of that, you may find this session a bit hard to follow. Otherwise, it should be a very fun session for you. I have lots of contents to go through, and I have 4 or 5 demos to show you within 60 minutes. And I got this strobe light. I hope I got the chance to show this. So I'll be going really quick, and I'm not planning to take any questions for this session. But after the session, I'll be in the Windows Azure Lounge area, basically for the rest of the day. So you're welcome to drop by to have any in-depth discussions if you like. So let's get started. So today I will talk about 3 topics. First, I will talk about performance, how to make your cloud services run faster, and how to make sure your cloud service will keep up the performance when they are under pressure. Second, I will talk about hybrid cloud services. I will introduce the options Windows Azure provides you to allow you to integrate your cloud services with your on-premises and legacy systems. And last but not least, I will tell you the love story between devices and cloud services. They complement each other so well that when we combine them together, we can come up with really powerful solutions. So that's the schedule. Let's jump right in. First, let's talk about performance. Performance matters for any computer systems. And it's actually important for cloud services. Why? Because on the internet environment, a slow service equals a broken service. When we design our cloud services, we always intend to believe our ideas are unique and special, right? Our company will show up on NASDAQ and will make a lot of money and will retire early. But the reality is, for any ideas, I'm not just saying the good ones, even for the lousy ones, right? There will be many people trying to compete for the same market. And for each potential customers, basically you have one shot. Let's say after whatever marketing effort you go through, a potential customer may come to your site and try out the service. And if your service doesn't perform, he will turn away and never look back. So you have to make sure your cloud service performs the first time and every time. Also in the cloud, reducing resource consumption, meaning saving money. Let's say on a local data center, you have a server that you pay $300 a month to maintain. What if you make the programs running on that server twice as efficient? You still need to pay $300, right? Because that server is not going anywhere. You still need to pay for the electrics, the cooling, the rent, and everything else. But on the cloud, if you can really reduce your resource consumption by half, you can return the other half to the cloud vendor and say, hey, Mr. Cloud, I don't need this much of a resource anymore, so don't charge me for that. And you can do that anytime. That's the elasticity of the cloud. And the flip side of this, if you can use the same amount of resources, but serve twice as many as customers, basically, you have a lower operational cost, you have a higher margin, and you can offer more competitive pricings, and you can improve your customer loyalty. So performance is extremely important for cloud services. And it should not be an after effect. It should not be, I will implement a function first, and then I'll consider the performance. Instead, it should be designed into your system at the very beginning. That's what we call performance by design. On the other hand, we also recognize the performance tuning as an ongoing process. But what we recommend here is that instead of trying this and that here and there, you should follow a systematic approach. Basically, this workflow involves the measurement, analysis, and execution steps. First, the measurement. Measurement gives you your performance baseline. It lets you to understand where you are right now. Before you can make any improvement, you need to understand your current situation. This is just like finding directions. Before you can decide which direction to go, you need to know where you are right now. And with the measurement, you can analyze the measurement data and establish and refine your performance goals. And you can identify bottlenecks in your system so you can better focus your efforts. And you can compare your current measurement against your performance goals so you know when to exit. And one of the golden rules in performance tuning is that always shoot for good enough, not shoot for perfect. Why? Because perfect means zero response time. It's perfect, it's zero response time, but it's extremely hard to achieve. So you have to think, does it worth it to shoot for the perfect? If you find yourself tuning the performance and your goal is to make it run as fast as possible, you really don't have a goal yet. You have to know what is good enough for your application. And finally is the execution part. That's the fun part. That's when you roll up your sleeves, apply different design and coding skills, and make your programs run faster. But that's just one of the steps in this process. And after you've done this part, you go back to measurement and you analysis again, and the process continues. And now let's talk about measurement. What you can measure. There's a lot of metrics you can measure. But the usual suspects including response times, resource utilization, and many other benchmarks. Among the response times, the client perceived response time is very important. That's the time between the client sending a request and the client getting all the response bits. So most of the customers, they don't really care how you generate and serve your responses. That's the time they care about, because that's how they feel how fast your website or web service is running. That's the time matters to them, so it should be matter to you. Resource consumption is also important to monitor, because whenever any of the resources, given if it's a CPU or bandwidth or memory or disk, whenever they got stressed or exhausted, they create this series of bottlenecks in your system that will slow down the whole system. What you can use? That's one of the best things about Windows Azure. You can still use your familiar techniques and tools to do a lot of things. For instance, you can still use performance counters. You can use system diagnostic namespace, WMI, etc. And there are many tools you can choose from. First party or third party, free or paid. Free, but if you're not care enough, we'll install some toolbars on your browser. All those kind of tools you can use. And with that, I will quickly jump into my first demo. In this demo, I will show you how to define and use custom performance counters to analyze the performance of your system. So in this particular demo, I'm trying to analyze the user access pattern to my pages. I have a very simple website with a home page, about page, and a contact page. Basically, I want to understand how many access per second I get on each pages. So let me switch to my machine. I can't duplicate my screen, so I have to look this way. It may look a little weird, but let's try this. Okay, here, for the sake of time, I already got everything written, but I will go through in details how the code is written, and I will show you the results. To define the custom counters, okay, before I go into the code, let me introduce the structure of this application. Here I have a simple cloud service with one web role in it, and this web role is just an ASP.NET application. There's nothing strange on that. And in my web role, I have my implementation of role entry point class. For those who are not familiar with this class, that's the class that is get loaded before your role starts. It will be loaded into a different process called IIS configuration process. That and its onStart method will be called. This is an opportunity to further customize your role environment before your web role or worker role actually starts. And the code here should be very familiar if you use the custom counter before. I'm checking if the category exists. If not, I'm creating a collection. Then I'm creating my performance counters. For this one, I'm saying how many times user accessed my home page. This is a count per second counter type. And I'm creating the same counters for all my other 2 pages. After that, I will just create the category. And by now, I already have my custom counters defined. But the custom counters, they log all the data to my local virtual machine. If you remember the talk from yesterday, the virtual machines are really stateless. That means when they are rebooted or reimaged for whatever reason, you will lose all your data on the virtual machine. So the solution to this is that I need to schedule a data transfer so I can transfer the data off the local machine to my Windows Azure storage. And here is how the transfer happens. I'm defining a transfer that occurs every 3 minutes. So basically, I'm saying I need to transfer my performance counter data to my storage, in this case, Windows Azure table storage, for every 3 minutes. And the data source for this transfer are my performance counters, 1, 2, and 3. After that, I'll just start my diagnostics monitor. By the way, if you use the Windows Azure diagnostics, that's the same pattern you follow. Basically, you do your tracing statement inline of your code. Then you schedule the transfer so the logs can be transferred to your storage. Then you just start the diagnostic monitor. This is all good, but there's one problem. When I define performance counters, it needs to modify the registry on my local machine. That needs elevated privilege. So I have to make sure this row entry class is executed in the elevated privilege process. So to do that, I will open my service definition file. And in there, I added one line. Let me bring it up a little bit. Oh, I hope you don't get dizzy. So here, I'm saying my row entry point needs to run in the elevated privilege. Note, just now I mentioned that your row entry point is loaded in a separate process. So when you are elevating the process, you are elevating this configuration process. Your web application itself still runs on your IIS application pool, and by default, it runs under network service account. So you're not actually elevating the web row itself. So that's the security measure we put in there. That's all I need to do to set up the performance counter. And to use them is really easy as well. I'll go to my only controller. This controller is serving off all my pages, my index page, my about page, and my contact page. And in each of the page, I'm getting a reference to the counter, and I'll just increment it. As simple as that. So now I have everything configured and everything is working. Let's see how the performance counters can be analyzed. Again, for the sake of time, I already have the cloud service deployed onto the Windows Azure. And if I go to the portal, you can see my cloud services are there. And this is my custom counters cloud service. And if I go to Monitor tab and wait for a while, look at the beautiful animations. And then you can see all my custom counters are actually surfaced here. I have my user access pattern for each of the page, and I can see the plot right on the portal. However, these counters don't appear on the portal automatically. To make them appear, you need to do something. You need to go to the config tab and make sure the verbose log is enabled. Once you have this enabled, all your custom counters will get surfaced on the portal. After you configure this, you can go back to the monitor page, and then we'll click on Add Metrics. You can see many more performance counters you can choose from than the default setting, and among which you can see all my custom counters here, listed here. So that's all good. I can see my performance counters on the portal. What are the tools I can use? Here I'm going to show you 2 other options, just to illustrate how many options are there. Here I'm going to the instance. I only have 1 instance of this cloud service, but I can use remote desktop, directly connect to the instance. I keep hitting the wrong button. I need to get connected, log in. And now I'm connecting to the remote virtual machine. I already got my my Profmon pre-configured and launched. And you can see actually there's some secret user accessing my website, causing the bars to go up and down. So that's the very traditional old Profmon monitor you can use right there. Let me disconnect from this. And just to show you how many options are there, I'm going to bring up a third-party tool. This is called Windows Azure Diagnostic Manager from a company called Cerebrata. What it does, it allows you to connect to your Windows Azure storage and present your performance data in a user-friendly way. For instance, if I want to see my performance counters, I already connected to my storage account. I'll select performance counters, and I got this wizard. I can say I want a live data feed, which is refreshed every 5 minutes by default. And instead of showing all the counters, I want to show just my counters. The good thing about this tool is that it understands what kind of performance counters I'm tracing. So give me this really friendly drop-down I can choose from. I'm looking for my user access pattern. That's my custom counters. I'll select everything, add, apply again. And now you can see my data is live on this portal. I can click on all the line chart to show them. So we quickly look at 3 different tools. We use the portal, we use the Profmon, we use a third-party tool to see how we can analyze our performance counter data. But there's still a little mystery there. This website is really boring. Although it's deployed, I don't think anyone is actually using it. But who are the users who's actually accessing this site? And let me review this secret right now. I will go back to Visual Studio if I can find my mouse cursor somewhere. OK. And if you've observed carefully, you can see that there's a little test running. So here I'm using a feature from Visual Studio Ultimate Edition. That's the Web UI and the performance test. This is a very simple to use tool. Basically, it allows you to record a browser session, and then you can set up loops to play back your sessions over and over again. So in this case, I recorded the browser session. Basically, I just opened the browser and went to various pages and record the session and just playing for, I think it's for 10,000 times. So that's how I generated the loads right from the Visual Studio. I didn't use any external tool or any custom tool for that. So now I can stop abusing the site. So that's my demo on the custom performance counter. I go through really quickly, but I hope you get some useful information. But before we move back to the slides, I want to show you something else. That is the Visual Studio Profiler. How many of you have used the Visual Studio Profiler before? OK, several hands. Oh, OK, lots of hands, actually. That's good. So it's very easy to use Visual Studio Profiler against your cloud service as well. So here's how you do it. The trick is when you deploy a cloud service, let me bring up the publish wizard. You have to make sure in the advanced settings you have profiling enabled. Let me zoom this in. So that's the little trick. Once you have this check enabled, the profiling agent will be deployed along with your role, and it can collect the profile data for you. And once you have this option enabled and you deploy your cloud service, you can go to the Server Explorer and connect to your compute instances. I'm not connected. Let me connect right away. So I'm connecting to one of my subscriptions, one of my many subscriptions. I'm connecting to my customer counters production environment. I say OK. And here you can see my deployment and my instance. And I can right-click on the instance. I say View Profile Report. This will contact the remote profile agent and generate the profile report for me. This will take several minutes. So for the sake of time, I already saved one report locally, which I will just show you. So this is one of the profile report. You can see I have a nice overview of my application performance. I can identify some hot path in my system. As you can see, because all my other controllers are extremely simple, the method of setting up the performance counters actually is the most expensive one. That's okay. Let's see if we can find something else. Let's go to the modules. And here I can actually find out all the processing time of each of my functions. If I drill in to my assembly, you can see the method. This is for my about page. This is for my contact page. This is for my index page. And you can see the processing time of each method. You can see for the about page, I have about 2 milliseconds. For the index, I have 12 milliseconds. And what's happening here? I have about a second to generate the contact page. Obviously, something is wrong over there. How do I find out what's wrong? I can just double-click on it. And you can see, I'm brought right to the code, and I have a little sleep over here. So by removing that, I can gain 30% of performance right away, and my boss will be happy. Right? That's the job security. Okay, that's my first demo, if I can switch this correctly. I have to use this. I have so many props on this desk. Okay, performance opportunities. I believe many of you have heard about this before, so I will go through this list very quickly, especially if you went to our Windows Azure keynote, you've seen all this. So basically, with our new Windows Azure SDK and the new hosting environment improvements, you have many opportunities to improve your system performance. Now we have .NET 4.5 support. So chances are, if you compile your application against .NET 4.5, your program is likely to run faster. It's likely to have a smaller memory footprint. And you can write asynchronous and parallel code much easier and much cleaner. And the Windows Azure caching is going GA. That's the caching cluster you can host by yourself. It's not an external service. It runs within your web role or worker roles. It's not an external service, so you pay nothing to call them. And your calls are not throttled because that's your own cluster. And you can define as big a cluster as you like or can afford. So you can define a very big cache cluster. All these two are very important, synchronous calls and caching. Because in any computer system, the slowest operations are I/O operations. So whenever you see opportunities to make I/O operations asynchronous or reduce the number of I/O operations, you have this tremendous opportunity to improve the performance. So that's why these two aspects are so important. And with Server 2012 and IIS 8, now we support WebSocket. Traditionally, the web applications all follow this request-response pattern. That means the server will sit there passively, wait for client requests, and when the client requests something, the server will start up and do something and then return the response. But the WebSocket allows your clients and the server to maintain an active two-way connection, and the server can proactively push any messages to the client when server sees fit. So that's a totally different communication pattern, and that enables a whole breed of new interactive applications. And the SignalR is an ASP.NET library. It can average WebSocket capability, and it provides a very simple programming model for you to build this kind of interactive applications. And for this part, I have to use this. For this part, I actually had two demos. I had one about how to use caching from end to end, and the other one is Fireworks, which will use SignalR, allow multiple users to play Fireworks on the same canvas. Both are really cool demos, but unfortunately, I can't show either of them because I don't have enough time. But the good thing is, I will be in the lounge area after this session. So if you are interested in caching and the SignalR, you're welcome to drop by, and I can show this demo as many times as you like. And if I run really quick, maybe I can come back to one of the demos. And for performance, when we talk about performance of cloud service, we should not constrain our thinking within one instance of our services. We should think the performance at a bigger picture. When you think performance at the bigger picture, you have more challenges, obviously, but you also have more opportunities. Here I will just highlight some of the capabilities Windows Azure provides you to help you to achieve performance at scale. We have CDN, Content Delivery Network, where you can cache your static content or some of the web responses to the CDN nodes so your customers can be served from the server closer to them instead of going all the way back to your server. We have Traffic Manager, which allows you to route your user traffic, depends on their geolocation or any other policy you would like to define. And with our IS8 support, we added a lot of improvements in multi-tenancy support. We allow you to efficiently host multiple websites on your virtual machines. And we have CPU throttling, which means your applications will be put into sandboxes, which you have total governance over that to control the resource consumption of each application. And many other features. I won't go through the complete list here, but I will show you a little animation to explain to you the Traffic Manager and the CDN and their relationship to your cloud service at a very high level. I hope this will be very easy to understand. So as you know, we have 8 data centers around the globe. And when you design a cloud service, you can deploy to any of the data centers. Let's say for American users, you deploy your cloud service to both East Coast and the West Coast. And when the user tries to access your service, you can use the Traffic Manager to route the user to either West Coast to East Coast so they can get optimized performance. So in this case, I'm routing this user using Traffic Manager to my West Coast server, and this user is happy. But what about a user that is far away from either of the data center, right? He will need to go through a very long network link to access your service, and it's likely the performance will suffer. So the solution to this is that Windows Azure provides 24 CDN nodes around the globe. They are put in carefully chosen locations, so that when the user accesses to your service, instead of going all the way back to your server, it can ask for the CDN nodes to see if there's any cached content on the CDN nodes. If you have your static content, like pictures, a style sheet, JavaScript, cached on the CDN node, the user can directly fetch those files from the CDN node instead of going all the way back to your server. So in this case, the user is going through a much shorter route, and the user is happy. And the other benefit of CDN is that it helps you to distribute your user traffic. Think about this. If some of the users can be served directly from the CDN nodes, they don't need to ever come back to your server. So with your same server deployment, you can actually serve a much larger amount of users. So that's a very high-level, quick overview of Traffic Manager, CDN, and your service deployment. And with that, I'm going to jump to my next demo. This is another high-risk demo, and you will see why in a moment. Basically, here I'm going to showcase the IS CPU throttling. In this demo, I'm creating a web service which contains 2 websites, one for my golden customer, one for my silver customer. And I want to make sure if there's some user generating a very excessive workload, I need to throttle the CPU so that other customers can get their fair share of resources. And let me switch back to here. I'm really getting hand with it. Okay, open the project, which is IS8. Don't need to save this. And this is a very innocent cloud services. I have a cloud service with one web role. And in web role, you can see I have the standard ASP.NET MVC template. There's nothing really strange here. And the only difference here, you can see I have multiple websites set up. The websites, they are using the same bits, but they are distinguished by different host headers. I have my gold hashbyte.com and silver hashbyte.com. So I will just launch this application. It's starting my local emulator. It's creating two websites on my local IIS, and I can serve both group of customers at the same time. This will take just a moment. Okay, this is actually expected because the default routing doesn't exist anymore. Let me go to my Gold site. Gold 2. By the way, I have the domain name entered into my local host files. That's why the names can resolve to my local machine. So you can see this is a very nothing unusual, except for this little link called the CPU throttle test. And if I click on it, it should bring me something back. Oh, it's thinking really hard. Let's give it a moment. And at this time, I can bring up my task manager so I can keep an eye on CPU usage. Yeah, basically nothing is happening. Okay, because this is a multi-site, let me bring up my silver site as well. Okay, how about this link? Okay, this one worked. So this guy is a little scary, right? This is a big yellow button, and usually when you see this big yellow button, you don't want to click it, especially in the build demo. Let's see, before we click on it, let's see what's the code behind. So here I have my CPU throttle controller, and I have a very little method that simulates a very heavy CPU-intensive computation. I'm starting 4 threads, and for each thread, I'm creating a tight loop and generating random numbers like crazy, right? All of you should know this is very bad code, and it's a tight loop, and will kill my CPU for sure. Okay, but just to make sure, let's try it out. I'm basically doing everything I'm told not to do on the demo. So let's see how it works. So I'm clicking on the kill CPU, and sure enough, all my CPUs are really, really busy, 100%. I'm just one user, one request, and I killed all my system. Okay, before my machine, actually, I think the cooling just kicks in. Before I kill my system for real, I will stop it. Okay, go back to my task manager just to make sure everything is turned on. It will take a while. Poor machine. Uh-oh. Come on, machine, you can do it. Yeah, what's happening here, the Visual Studio is tearing down my web applications. It deployed for me on IIS, and my CPU usage should drop down pretty quickly. Yeah, now I understand why I shouldn't do this on the demo. Oh, yeah. Come on, you can do it. I have faith in you. Oh, okay. Okay, I told you it's bad, but hey, that makes my point, right? It's really bad code. Okay, let me start the Visual Studio again. I'm sorry, Visual Studio, but you did a good job. And it's starting somewhere. Okay, let me open this again. So that was really, really, really bad. And all it took is for one user to generate a really bad workload. Of course, that's part of my bad coding, but you got the point. So I'm relaunching the website. Let me restart everything again. But this time I will not kill the CPU. So I'm starting everything up again. This will take a minute. Then as it's working, I will bring up the IIS manager. Where's my mouse again? Okay, I brought my IIS manager, and I hope my sites are up. Okay, it's up. And you can see on the IIS manager, actually I have more application pools than I expected. It seems the previous tool didn't get killed properly. So let me just clean it up a little bit. Yeah, I think it's going down. Oh, this is fun. This is fun. Okay. So the other two should be gone by now. And they are all there.
How many event processes do you have? Do you have the other processes still hanging around?
I don't think so, but we can take a look. There's one guy. Stop. Stop. Failed to stop. How stubborn is that? Oh, this is too much pressure for the machine. Okay, let me do a refresh. Okay, now it's getting there. I have to watch my time. Okay, 20 minutes. I still have time, so I can wait for a little while. Anyway, this two are stopping. I will ignore them. Let's just keep going. Okay, now let's relaunch my site. I should see two new application pools deployed on IIS. Refresh. But anyway, I can show you the configuration anyway. So to configure the CPU throttling on Internet Manager, all you need to do is to select the application pool and go to Advanced Settings. Here you can see the CPU throttle settings. The value you need to specify here is the 1,000th of a percentage. So if you say this application pool can use up to 40% of my CPUs, I will say 40,000. And when that happens, when that benchmark is hit, I can choose no action or kill my worker process. Basically, that's the options you got from IIS 7, right? Which is really not nice. You don't want to shut down your server just because of that. So now in IIS 8, we have two more options. You can throttle the process. That means you don't get more CPU cycles, but your worker process is still running. And you can also set it to throttle under load. That means your application can actually go above the quota you got allocated, and it only be throttled when the system is under pressure. So this is all nice and easy. We can configure this manually on the IIS Manager. But for the cloud service, what we want is to automate this process. Basically, when we deploy our cloud service, we want these settings to be automatically applied to our raw environment so that we don't need to configure this manually. And let me show you how to do that. Let me go back to this thing and stop applications. And in this case, I will do in the row entry point again. That's my favorite place. And I will use the code snippet, build 2012, and row entry point. The code is a little scary here, but once I go through it, it should be really simple. So here I defined a simple class, which defines my custom profile. That can be any class you like. The profile is really simple. I'm saying for this username, I will throttle the CPU by this much. And when my row, before my row starts, I will initialize my policies. Basically, I'm saying for my Gold users, I'm allowing to use up to 40% of my CPUs. For my Silver users, you don't get as much. You get 30%. Then I will just use the Server Manager. This is part of the Microsoft Web Administration assembly. This assembly allows you to call into IIS Manager to configure IIS programmatically. So here I'm getting an instance of the manager. I'm getting all the application pools, and I'm finding the application pool corresponding to my site. Then I will just do the CPU throttle settings. At last, I will commit the changes. So this is very straightforward code. And let's try this again. There are 2 zombie application pools over there, so it even doesn't build. Okay, it's being used. I really have to kill these processes. Okay, how about I do an IIS reset? Well, that's, yeah. This will take just a moment. Okay, now it's restarted. Just to make sure, let me refresh. Maybe my manager is not. Do I still have the application running somewhere? Interesting. Okay, I don't think I'll waste much more time on this. So basically, after you relaunch, you try to kill the CPU again, nothing is killed. So you have to use some imagination for that. Yeah, that's a good point. I'm not giving up yet. Okay, let's kill the emulator. Why not? Why not? Now my deployments should be gone. Let me actually exit the whole thing. Please be gone. No, they're sticking there. How can I remove them? Yeah? Does not exist, of course. Yeah, maybe the UI is not refreshing. Okay. Okay, let me refresh at the higher level. Okay, now it's gone. Okay. Okay, killed you. How about that? Okay, now let's try to kill the CPU again. Oh, I just can't wait to kill my CPU again. Okay, now everything is going back to normal. I bring up the performance counters. Okay, my site is up with a wonderful error. Okay, now let's go to my Gold site again. Gold. Did I type it right? Okay. The set came up. I try to kill my CPU and maximize this task manager so you can get a better view. So you can actually see the struggle over there, right? The processor is trying to grab more CPUs. It got pressed down and it's trying to do more. But regardless, my CPU is not saturated. Actually, I can bring up my Silver site as well. And I will do the same from here. So imagine that. I'm having 8 threads, all trying to run a very tight loop to kill my CPUs. But you can see my system sustained the CPU usage quite nicely. So that's that. That was a high-risk demo. Okay. Okay, now we are ready to go back to the slide again. We just did this exciting CPU throttling day. And now we are ready to jump to the next session. So just a recap of the performance part. We see the performance counters. We show many tools and new capabilities. And now let's talk about the hybrid cloud. Unless some of other cloud vendors who come to your data center and say, hey, you know what? Everything you're doing so far is wrong. You should move everything to the cloud right now. Why they say that? In my opinion is that That is because they have nothing on your data center. Right? Am I allowed to say that? Yeah, it's okay. It's true. So, but for Windows Azure, the messaging is different from the beginning. Right? We want you to enjoy the benefit of the cloud, such as elasticity, high availability, and all the good things. But at the same time, we understand that enterprises are made of hundreds of applications. It's just not practical to ask every people to come on to party on the cloud. That's just not true. And the customers really don't care where your services are and how the services are composed. They just want to get their business done. And this is not a simple task. And so it needs a very comprehensive solutions. And the Windows Azure tackles this problem in 3 different angles. The first, loosely coupled services. Second, connectivity. And third, messaging. All Windows Azure services are loosely coupled. They work great together, and they work just as well if used separately. So there's no one or nothing buy-in here. You can pick and choose whatever services that make the most sense to you at any given point. You can choose just to use SQL database. You can choose to use table storage. You can choose to use Service Bus along with other systems. So with all those services, we're bringing the cloud benefits to your data center. So that makes sense. So instead of asking you to jump to the cloud, we're bringing the cloud to you. And the second piece of the puzzle is the connectivity. You may have hundreds of applications written in different times, using different languages, running on different platforms, but there's often one commonality among them, which is they are connected on a TCP/IP-based network. So this allows Windows Azure to provide a really elegant solution, which we call virtual network. So basically, with virtual network, we allow the virtual machines you have on Windows Azure, as well as your machines on your on-premise system, to be connected together as if they are on the same local network. This is just beautiful, right? In many cases, you don't even need to change any of the code. You just connect to a different IP address, and everything still works. And we allow our cloud services and virtual machines to work together nicely. They can be working in the same security boundary, so you can have really efficient and secure communication among them. And in addition, we have the Service Bus Relay. For those who don't know this Service Bus Relay, and that's a Windows Azure service that allows you to connect any machines, any 2 machines over the internet. The machines don't need to have public IP addresses. They don't need to have static IP addresses. They can be sitting on the net behind the layers of firewalls. But with the Service Bus Relay endpoint, you can connect the 2 machines together. And to better illustrate the connectivity options, I will show you this animation. I hope I can explain to you what are other options out there. At the basic, we have Windows Azure Cloud Service. A service can have multiple roles. Each role can have multiple instances. They are put behind the load-balanced public endpoint that your customer can access. So that's the basic connectivity. We also provide internal endpoint. Internal endpoint is private to your cloud service. It's not load-balanced, but it allows you the role instances within your cloud services to directly talk to each other. Right? You can address an instance role and just send a message to it. And we also support instance input endpoint. This is not in this is not introduced in 1.8, but in 1.7. I don't think many people knows about that. So this is another type of public endpoint, but with a port range. And by selecting different port, you can actually address different role instances directly from outside of the cloud service. And if you have multiple cloud services, or if you have cloud services and your virtual machines, you can put them together on the same virtual network so that they seem to be connected on the same local network so that they can communicate with TCP/IP just as normal. And the virtual network can be further extended to your on-premise system, which means you can take a segment of your on-premise network and connect them to your virtual machines running on the cloud. So they seem to be on the same local network, although they are totally remote. And in addition, we have the service bus relay endpoint. That means for any computer, whether it's running on cloud or on-premise, you can go to service bus and register a relay endpoint. And with this relay endpoint, any other machines, either it's on-premise or on cloud, can connect to this endpoint and talk to the machine. I mean, look at that. How hybrid do you want to be? I mean, there's so many options, right? But for this talk, I don't have time, and frankly, not much specialty as well, to go deeper than this. I would recommend you to watch these two sessions. I think they both have occurred. So you can go to channel 9 to watch the recordings. And now let's talk about the messaging. I will go through this really quickly as well. Basically, messaging-based integration is a very powerful and a proven integration strategy. This is not just a Haishi saying that. This is people with hundreds of years of collective integration experience saying that. It's a proven technology to allow the systems to be integrated, but at the same time to remain loosely coupled. It enables a lot of powerful scenarios, which I don't have time to dig deeper here either. But here, that's the good thing about the build. There's about a session about anything. So you can go to this session. I think this session is coming later today. I'm not sure. But anyway, you should definitely look into that if you want to understand more about messaging-based integration using Service Bus. And I don't have a demo for this session, but in my last demo, I will basically cover the Service Bus messaging part as well. So now it comes to my favorite part, the love story between devices and cloud services. And actually, for this session, I only have one slide. And for this slide, I want to do something unusual, you can say. So I'm not going to talk about this slide. I will just bring it up on the screen, and I will ask you to read and think about it. I think it says everything I need to say. Here we go. Okay, you're done reading? Do I need to say more? I don't think so. Right? The best device applications are connected applications. That's just as simple as that. So with that, I will jump to my last demo. Do I still have 7 minutes? Okay, good. So the last demo is a bit complex, and it's yet another high-risk demo. Involves this strobe light. I will introduce the scenario a little bit. So in this scenario, I'm a QA professional working for a global manufacturer. I need to travel from factory to factory to inspect the parts from assembly lines. Basically, I need to pull some parts out of the assembly line and inspect them to make sure they are made up to the spec. And all my specs are saved safely on my local data center in my headquarters. And now my problem is that how do I access those specifications? One very simple solution is that I create a mobile application like my spec reader, if you will. It allows me to download and read my specifications. But there's still some problems with this design. And first, there's a lot of data to be downloaded. Second, I have to make sure the data on my tablet is in sync with my server, which is not necessarily an easy task. And what's more important is that this application is just fancy box of files. It doesn't really provide me any additional values. So instead of doing this way, I will turn the design around. I will use the rich data capture capability of my tablet. I will say I will take a picture of my part. I will send a picture to the server, and I will have a service running, which will access the local specs and do image analysis on the parts and send me the result. This sounds pretty cool. Basically, I can take my tablet and go around, take pictures, and just forget about the spec synchronization. But there's still some problems. This analysis portion on the server takes a long time. I can't just sit there and wait the server to finish its job. I need to travel around. I need to keep going. So ideally, I should be able just to take pictures as quickly as possible. Then I'll just wait till whenever the server is ready, it will push the data back to me. So instead of sending the pictures directly to the server, I will send a picture to the service bus queue. And the server is monitoring the same queue as well. And the server worker process will pick up my work from this queue at its own pace. And once it's done with its job, it will send a result from a service bus topic. Basically, a service bus topic allows you to design this publish subscription pattern that you can publish a method to multiple recipients. For in this case, I will subscribe to all the messages published to this topic so I can get all the results. And before I go into the architecture, let's see how this works. This will be dangerous. Okay. Let me switch to my tablet, if I can. And it's powered down. Okay. Here I already have my application deployed. This is a simple Windows 8 application. And I have some of my sample parts. So basically, this is a little mock-up of some of the parts I could analyze. Actually, let me get the one that is made to the spec. So this one is actually one of the cracked part. So all I need to do is to put this down. And actually, the lighting is very important because I have to get a good capture of the image. There's so many shadows here. I have to get a really close-up shot, and I'll explain why in a moment. I think that shadow will mess me up, but we'll see. So now I'm taking a picture. The picture is sent to the server. The server is running analysis on the image, and it actually matches with the spec and tells me, okay, this part is good. So let me try a different part. Actually, this part is bad, but I don't know if you can tell the difference. This is the right one. This is the wrong one. Can you quickly tell the difference? Okay. Yeah, it seems I don't need this program after all. So let me see how the server says about this. Let me take another shot of this guy, and I'll say OK. And sure enough, the server compare the spec and see, hey, you're missing a slot over here. So I can keep running different parts, but now I am going to bring up a really, really bad part. And let's see what happens here. And that's the really, really bad part. And I say, OK, the picture is sent to the server. Server is running analysis, and it says fail. This is totally failure. You should not have a cat in your production line. So now my server is actually deployed on Windows Azure. It's running. And my Windows 8 tablet is running as well. But now how do I extend this system? Let me go back. Let's say the guys in the factories, they see this application, they think, oh, this is so cool. How about we want to get something of that? So what they want is that when something happens, really bad happens, like the cat running on the production line, they want to get an alert right away on the factory floor. So here's the system. They come up. Here's I have my strobe light for my production line. And I have a USB controlled power switch, so it can control the power on and off using the USB command. And this has to be an on-premise system because this is a local USB port. If I deploy this on the cloud, it will just not work. So now my factory got a wonderful programmer and start to write this program. Actually, because he's so good, he's already done that. Actually, let me, I know I'm running out of time. Just a moment. Actually, let me turn off the strobe light for a moment, just in case I don't trigger the alarm accidentally. Okay, I think I'm good. Now I can show you the code. I did something secret I want to explain to you. So, okay, here's the code. It's very simple. It's a console application. Basically, I'm saying my USB cover control initialize. Yeah, it's already going off. So just to show you, because I already have the signal set, let me clear this one. It's a simple USB power control. I'm in inertia, I can't even talk. I'm starting the service. Then I will use the service bus namespace manager. I'm checking if I do have a subscription to the result topic. If not, I'm creating a subscription. But in this case, I'm adding a filter. This is a SQL filter that you can put simple expressions on it. In this case, I'm saying only the assessment level equals 3. That means something really bad happened. I'm going to respond to the message. Then I will just start in the message loop and wait for the message. I will start this. And now I will try this again. Actually, instead of trying with cat, I've done everything I should not do in the demo. So let me just do this. I will take a picture of a happy evangelist to see if this will work. Say OK. It's sending to the server. And of course, the server doesn't like it. Thank you. Okay, let me kill the alarm before it causes any damage. Actually, I'll just turn it off. Okay, let's go back to the slide. I promise I'll be done really, really quick. So I don't have time to go show you all the code, but I will show the code snippets on this diagram. So on the Windows 8 tablet, I'm taking pictures using the Media Capture UI, Camera Capture UI. Then I'm generating very small thumbnails. I'm only using 95 pixels wide and 60 pixels high. So that's why I have to get a really close-up shot so that I can have enough pixels to work with. After I get the thumbnails, I will send a message to a Service Bus queue. It's very simple to use that. I'm using the Service Bus Windows 8 library. That allows me to interact with Service Bus right away. I'm sending the message, and on the server side, my server is picking up this message from the same queue, and it will deserialize the message, the images, and it will run some basic image analysis on the pictures. Then it will generate the result and publish the result to a topic. And my tablet is subscribing to all the messages, so I can get all the results. But on the factory floor, I have an on-premises system. I'm only subscribing to the severe errors. Then I will turn on my strobe light. So the summary, we talked about a lot. That's all. The resources, this is very important. Windows Azure Training Kit. This is a kit maintained by our team. It's a very comprehensive kit. Contains many tutorials, presentations, and hands-on labs. Actually, this is how I and many of my colleagues first started with Windows Azure ourselves. So it's highly recommended you check it out. And we have this Windows Azure samples organization. Basically, it's a list of repositories containing many end-to-end scenarios, and the list is keep growing every day. And all the demonstrations you see today will be end up in one of those repositories pretty quickly. And you can follow my blog to see announcements of those availability. You can find me on Twitter, and for the Chinese audience, 你们可以到新浪微博上去找我. I know not many people understand that, but that's in Chinese. Okay. So feedback is very important to us. Please send your feedbacks. And especially if you want to see this kind of sessions in the future, please say so in your feedbacks so you can bring me back. And with that, thank you very much. Enjoy the rest of the build.